Hey everyone, do you have any questions so far? Yes, I do, Dr. Benny. I know how to write the law of mass action for a homogeneous or heterogeneous reaction, and that expression is equal to the equilibrium constant. I'm wondering what information can the value of an equilibrium constant tell us about an equilibrium reaction? I'm glad you asked this question, Benjamin. The magnitude of an equilibrium constant can tell us whether products are favored or whether reactants are favored when a reaction reaches chemical equilibrium. Can you tell me how to write an equilibrium expression of an equilibrium reaction? Of course I can. An equilibrium expression is the product of equilibrium concentrations of products over the product of equilibrium concentrations of reactants. Each concentration of reactants and products is raised to their stoichiometric coefficient as their power. Yes, I can tell that you have been reviewing the content. Okay, let's consider two scenarios. First, if a K value is much greater than 1, what that tells us is that the product of equilibrium concentration of products has to be much greater than the product of equilibrium concentration of reactants. We don't know how far the reaction is going to proceed to form products, but we know we're going to have more products than reactants present at equilibrium. Does that make sense? Yes, it does, Dr. Benny. If a K value is much less than 1, does that mean we would expect to have more reactants than products present at equilibrium? Correct, Benjamin. If a K value is much less than 1, it implies that the numerator is going to be a smaller value than the denominator. Since the denominator is the product of equilibrium concentrations of reactants, the reactants are going to be the predominant species with small amounts of product present at equilibrium. Finally, every equilibrium reaction has its own K value, and that can be affected by a number of factors. What we discussed right now is how to write an equilibrium expression and how to make a qualitative prediction based on the magnitude of the K value.